In this lecture, we'll talk about integer exponents and quotient rule. We will use a 0 as an exponent. We'll use the negative numbers as an exponents. We'll use a quotient rule for exponents, and we'll use a combination of the rules for exponents. Let's get started. The first rule that we'll go over is a 0 as an exponent. To understand that, we will start with what we already know, and we will observe the pattern in order to figure it out what happens when you have a 0 as an exponent. We already know that 3 to the power 4 equals 81. 3 times 3, 9. 9 times 3, 27. 27 times 3 is 81. Now, I'm going to decrease my exponent by 1, keeping the base same. 3 to the power 3 equals 3 times 3, 9. 9 times 3, 27. Let's keep decreasing. 3 to the power 2 will be 9. 3 to the power 1 will be 3. Now let's look at the pattern, what happens on the right side. Let me get the pen here. You had 81, and then 81. You had 81, and then 81, we got the answer 27. How? We must have divided 81 by 3 to get 27. From 27 to get 9, I must divide 27 by 3 to get 9. From 9, I got my answer 3. Again, 9 divided by 3 will give me 3. So I already know what will be my next line. I must divide 3 by 3 in my next line. So I already know my right side will be 1. Well, the left side is already 3 to the power 0. This is how you will get 3 to the power 0 equals 1. Any number as far as it's a real number to the power 0, which will equal to 1. So you definitely want to copy down this rule, a to the power 0 equals 1. In the next slide, I'm going to show you an example using this rule in 4 different ways. Let's bring the 4 problems. The first problem is the direct application of the rule. A to the power 0 is 1. 7 to the power 0 is 1. Now, in the second example, we have a negative number, but as far as it's the part of the base, the answer will be still a 1. So negative 16 to the power 0 will be still 1. Here, you have to be careful because the negative sign is not the part of the base. So you want to keep the negative sign as is. 8 to the power 0 is 1. So if the negative sign is not the part of the base, you will have the answer negative 1. Here, 13 to the power 0, 1. 2 to the power 0 is 1, and we are adding. You can add, you can subtract, or you can multiply depending on what the sign is used. 1 plus 1 is 2. So this is a 0 as an exponent. Now let's follow the pattern again to understand the negative to positive exponents. I'm going to use a same example. 3 to the power 4 is 81, we saw previously. 3 to the power 3 is 27. 3 squared is 9. 3 to the power 1 is 3. 3 to the power 0, now we know, is 1. So in the answer on the right side, imagine what will happen. I have divided 81 by 3 to get 27. 27 divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. So on my right side, I will divide 1 by 3. So that will give me 1/3. So this is how your next row will be. 3 to the power negative 1 equals 1 over 3. It's the same thing as 1 over 3 to the power 1. So to understand this better, we will write down 2 rules which will show us how to change the negative into positive exponent. Now, I have shown you these two rules based on where my negative sign is on the top or the bottom. So on the top example here, your base is on the top. There's nothing in the denominator. So if you see that, you bring down the base on the bottom and you must write 1 on the top. As soon as you bring down the base on the bottom, you see that exponent became positive. We changed from negative to positive. Now, if your base is on the bottom and you have exponent as a negative, then you want to move your base to the numerator. In that case, you have nothing left except 1, so I did not have anything in my denominator. And now you see that my exponent becomes positive. So if you don't have anything left in the denominator except 1, there's no need to write. But if you have 1 on the numerator, then you must write that number. If you bring the whole thing down, nothing left on the top, you must write the 1. Let's look at the example to understand these two rules better. Here I have two examples. First one is a 5 to the power negative 2. Now 5 to the power negative 2, the base is 5, which is in the numerator because there's nothing in the bottom. So what I can do is it has to come down in the denominator first. If it comes down in the denominator, then nothing left except the 1 on the top. As soon as you bring the 5 down, keep in mind the power, which was a negative, now it becomes positive. You can leave like that, or if you want to evaluate furthermore, we can. In that case, I will multiply 5 times 5 to get to 25. Either or will be correct depending on the instruction given to you. In the second example, I have base which is in the denominator and I have power negative. So if my base is in the denominator with the negative power, I must take that on the top. So if I take that on the top, then nothing left on the bottom. So I have 2 and then the power will become just a positive. So I have 2 to the power 3, basically. You can leave like that, or if you want to evaluate, then you will do 2 times 2 times 2, and that's going to give you 8. If you want to put the 1 here, I mean, some people like to put the 1 here, but I would not recommend. There's no need to put the 1 there. It's just 2 to the power 3, which will equal 8. Let's try 2 more examples. In the first one, I have a negative 2 to the power negative 4. Now keep in mind, this is a separate, right? Because the 2 is attached directly with this negative 4. The negative sign stays where it is. So here I have fraction bar. The 2 is on the top. First thing I will do is bring it down. As soon as you bring this down, you will have the power to be positive. So now nothing left on the top except 1. You can evaluate that furthermore. That should give you negative 1 over 16. In this case, I'm not going to evaluate, but you can. Second example, the negative sign right there stays as is. This time, the base 3 is on the bottom, but power is negative. The whole thing, the base has to go on the top. The negative sign is there. 3 goes on the top, nothing left on the bottom except 1. You can write the 1 in the denominator, I'm not, and then the power will be 2. Power becomes positive. You can leave like that, or if you want to evaluate, the answer will be negative 9. Because negative sign is not the part of the base, so you will just multiply 3 square and write the answer to be negative 9 if they ask you to evaluate furthermore. Let's do 2 more rules. In this case, let's understand first the rules. A to the power negative m over b to the power negative n. If you look here, what I did is I just flip-flopped the numerator and the denominator. So if you see that the numerator went down, the exponent becomes positive. The denominator went up, the exponent becomes positive. Now, you see that the base are different. Just keep that in mind. In the second rule, I have a fraction a over b with the negative exponent. So to make the exponent positive, I just flip my fraction a over b into b over a. I have still the parenthesis around, keep in mind. So if you have a fraction and if you have a negative exponent, you can just flip the fraction inside and that will switch the exponent into a positive. So these are more ways on how to change the negative exponents to the positive. Now let's look this with the example. Here I have two examples. In the first example, I have 6 to the power negative 8 over 7 to the negative 11. Now keep in mind that the base 6 and 7 are not same, right? So what I'm going to do is I'll move this on the top and I'm going to bring this on the bottom, and that would be it. So I will have 7 to the power 11 in my numerator, and I will have 6 to the power 8 in my denominator. The exponents are large here, so I will not bother here to evaluate. I'm just going to leave it like that. In my second example, 3/4 is inside the parenthesis, but this time the power is a negative. So what you can do is first you want to keep the fraction inside the parenthesis, but then what I did is I just flipped it. As soon as I flipped it, my power becomes positive. Now, if you want to evaluate this using the rules we learned in the previous lecture, you can. In this case, we will do 4 times 4 is 16, and then we can do 3 times 3 is 9, or you can leave as 4/3 to the power 2. Choice will be yours. Let's look at 2 more examples, just an indirect approach here. So in the first example, I have 4k to the power negative 6. Now keep in mind, 4 has a power 1 already, which is positive, which means I'm not going to touch the 4. The 4 will stay where it is. Only thing I have to change is k to the power negative 6. K is in the numerator, so in order to make the power positive, the k must go down. As soon as you bring the k down, the power 6 will turn to the positive. In the second example, 3 already has a power 1, which is positive. I don't want to change the position of 3, so I'm going to leave the 3 where it is. In this case, m is in the denominator, the power negative 7. That needs to be changed. You need to move the n on the top first. As soon as you move the m on the top, let me write this again, 3, and then I'm going to write m on the top. And then as soon as you do that, the power 7 will become positive. So nothing left on the bottom. Now we can talk about the quotient rule. Quotient means to divide. So in here, you have to make sure that you're dividing first, and then the base has to be same. So you keep the base same, and you are subtracting just the power m minus n. So a to the power m divided by a to the power n equals a to the power m minus n. I'm going to show you in the next 2 slides the variation using the quotient rule. I'm going to show you an easier approach to apply this rule because the end goal is to have the answer with the positive exponent. Here I have 3 different examples, and as you can see that all of them are dividing, and I'm going to try to use the quotient rule. In the first example, I have x to the 11 and x to the 8. Now, I do it a little bit differently. So first thing I check that the powers are positive. Second thing I check, I circle where my numerator or exponent is higher. So in this case, the 11 is higher than 8. 11 is in a numerator. So once you know that 11 is a numerator, I'm going to keep my x in the numerator, and I will subtract 11 minus 8, which will give me 3. And that's it. That's the quotient rule. Now, if the same approach I use in my second example, I end up having a negative number, which I then have to change to a positive. Because if I do 7 minus 10, I'm going to get negative 3, right? So to avoid that, what I usually do is I look first that the exponents are positive, and then I circle the larger exponent. 10 is higher than 7. 10 is in the bottom, so your x this time will stay in the denominator. If your x stays in the denominator, nothing left except 1 on the top. And now you can do 10 minus 7, and that should give you positive 3. So by doing this technique, you avoided a step of changing a negative into a positive, right? But both will be correct, either or. In the last problem for this slide, you see that the power are negative. So first of all, I would like to change that into a positive by just moving up and down. And once they are flipped, the power become positive. Now the same approach. 8 is higher, and that's in the denominator. Therefore, I'm going to keep my x in the bottom. And then nothing left except 1 on the top. In this case, now I can subtract 8 minus 5, and that will be 3. So the answer will be 1 over x to the 3. So I hope you understand. Otherwise, you can go over the previous slide where I explained you how to use the quotient rule. Let's do 2 more examples. Okay, so again, you can use a quotient rule subtracting, but I would always like to change that to the positive first. So in this case, I'm not going to move the x to the 10 because it's already positive. This x to the power negative 15, I'm going to bring it down because I want the x to be 15 to be a positive number. So then nothing left except 1 on the top, right? So now you see the cross 10 and 15. You're multiplying on the bottom, which means I'm just going to add my powers 10 and 15, which will give me 25. So what I did basically here is I brought down the negative 15, changed into the positive, and because the x, now I'm multiplying on the bottom, I added. So use the product rule. In the last one, same thing I will do. Leave the x to the 17 as is. And then you will take this x to the negative 11 on the top. As soon as you do that, nothing left on the bottom, and the power will become positive. Once again, I'm going to use the product rule. Leave the x, 17 plus 11, you will add, that should give you 28. So the final answer is x to the 28. So these are the different ways you can change the negative into the positive. Now I will move on to the combination of rules where we will apply more than one rule. Here's our first example. 5 to the power 3 to the power 2. So the first thing I will do is remove this parenthesis by multiplying power and power. That will give me 5 to the power 6 over 5 to the power 2. So I'm just going to use the last rule we learned here, quotient rule. 5 is the base, which is same. In this case, first you need to decide where you're going to keep your 5. 6 is higher, and that's on the top. 5 will stay on the top, and you will subtract 6 minus 2. That will give you 5 to the 4th. You can leave the answer like that. Or if you want to evaluate, then you can go furthermore. 5 times 5 times 5 times 5. That will give you 625. I'm just not doing in this one, so I will leave my answer as 5 to the 4. Let's look at another example. Now in here, you can change the negative into the positive power, or you can use a product rule. There are different ways to approach the same problem. Why I can use the product rule? Because the base is same y, and I'm multiplying. So I'm going to keep my y as is, and I'm going to add my exponents. Negative 8 plus 5, negative 3 plus negative 2, which will give me y to the negative 5. Now this one needs to be switched into the positive power. Look where y is. Y is in the numerator. So you need to bring it down in the denominator. When you do that, there's nothing left on the top except 1. So you want to bring the y down. With the power, 5 becomes positive. There's nothing left on the top except 1. Let's try another example. In this case, I have a parenthesis on the top and I don't have a parenthesis in the bottom. So what I would do to open the parenthesis, I'm going to multiply 2 to the negative 3, which will give you negative 6, and I'll multiply 4 to the negative 3, which will give me negative 12. So that's the first step. The denominator stays as is. Now, what I can do is I will flip-flop my position of m and n. So what I did here is that, let me explain. I left my m to the power negative 2 as is, as you can see. I left my n to the power 5 as is. What I did is I brought this m to the negative 6 down, became positive, and I brought down the n to the power negative 12 down, became positive, right? And that should work because now I can just use the product rule. Okay, let me get the eraser here so you can see clearly my next line, what I did. So now I'm just going to use a product rule, and that will give me m to the power negative 2, m to the power 6, which will give me m to the power 4, negative 2 plus 6, and n to the power 5, and n to the power 12. That will give me n to the power 17 because I added 5 and 12. So this is the way you can use a combination of any rules we learned, the product rules, the power rules, and the rules for changing negative into positive. If needed, you can repeat this lecture again.